I'm here to talk about making CAD models watertight, both the why and the how. So first, the why. Study after study shows that CAD data is sensitive. It's a fact that even vendors acknowledge, and there's a whole industry out there with products such as CAD Doctor, CAD Fix, Magic Heal, amongst others, with entire conferences. A Sandia study showed that in monitoring their own engineers, that over 70% of their time went to mitigating the design pipeline. And if you talk to those authors, as I did, you'll see that that number is growing. But I really didn't need personally to see this study because as a licensed design engineer analyst for 10 years, I lived this on a daily basis. And I could tell you that it affected my end product as well as my morale. So when I saw isogeometric analysis and heard about uniting computer-aided design and computer-aided engineering using the same definition of NURBS, I thought, hey, this is the future. So what happened to the computer-aided rapture that we were looking for? Well, let me demonstrate why with an actual CAD model. So I got this recently from an auto manufacturer. And this model looks good in your graphical user interface. It is the design intent. But for a downstream user who wants the surface geometry, this is what they inherit. And these independent surfaces, you cannot solve physics problems with them. You have to mesh it, and this is why we mesh them. So what is the impact downstream? Well, let's take car crash simulation. So your typical car crash simulation will consist of, for a full model, state-of-the-art, 5 to 10 million elements. And it takes about 5 to 7 weeks to actually make these models. And surprisingly, the work is offshored to India. And this is a very common model way of doing things. You know, we are in a meshing arms race where we want higher fidelity. We have more computing power. We want more accuracy. But I'm here to tell you from the mechanics side, you can't solve things by throwing more mesh at it. There's some problems that you just can't solve that way. So what do we need? Well, downstream users of CAD models need smooth, watertight models, period. So how do we do it? Well, if you look at the classic surface-surface intersection problem as the roadblock, you won't solve this by doing it the classical way. This has inhibited the solution for a while. So let's look at an alternative. Let's look at people who do this as a craft, Class A surface modelers in the auto industry. You know, in their job, if you watch them, you'll find that they move from surfaces to isoperimetric curves back and forth, and they do it manually. But what you'll find is if you actually look at it mathematically, you can find an isomorphism between these surfaces and these sets of isoperimetric curves. And if you manage it correctly, you can use them as a proxy to make these surface intersections. And so you can make these non-watertight B-reps and transform them into watertight, smooth, continuous models that are instantly available for downstream users. But even better, it's done fully automatically, and it maps also the parametric UV space, making the algorithm closed form. So you can implement it in any of your favorite CAD products. Doesn't necessitate some sort of new data structure. So for the engineer analysts, like I was in the past, racking their brain, hitting their head against the keyboard all day, we can eliminate the meshing and the healing. Here's an actual model. I did not mesh this, I did not heal this. I ran the algorithm in the CAD software and ported it to LS-DYNA, where it was instantly analyzed and got better results because you have smooth, exact geometry with isogeometric analysis. But there's an interesting addition to this. We just looked at the bivariate surface paradigm, but the interesting thing is that this technique scales. So what you can't do in CAD currently, you can do with this, which is making volumetric booleans, trivariates, using these isoparametric curves. And if you take that a step further, what about adding in an invariant or metadata model? So you can encapsulate all your data that you would want in modeling. So this includes material data, color, building information modeling, you name it. So I'll leave you with this. Is the future non-watertight B-reps? I could tell you in the past, it didn't even suit my needs then. So I present a different future, which is invariant watertight modeling. And I'd like to hear your thoughts on the bus later.